Solving exponential equations can be kind of tricky at times. One of the main ways to do it is if your variable is in your exponent. If you have something raised to a power where the power has an exponent, has a variable in it, then see if there's some way where you can write both sides of the equation using the same base. Can you rewrite both of them as 2 to a power or 3 to a power or 5 to a power? Because if the bases are the same and they're equal, then the exponents also have to be equal, and you can actually just drop the bases. In other words, 2 to the third equals 2 to the x can only lead to 3 has to equal x because there are no two different powers of 2 that would have the same exponent. So let's take a look at an example. What if we solve 1 over 27 raised to the x is equal to 81? Now, 27 is 3 cubed. 81 is 3 to the 4th. So can we write both of these as 3 raised to some power? Because it would be kind of tricky to write 81 as 27 raised to a power directly. But we could write this as 1 over 3 cubed raised to the x. This is 3 raised to the 4th. 1 over 3 cubed is the same thing as 3 raised to the negative 3 power to the x. And when you've got a power to a power, you can multiply the exponents. So this would be 3 raised to the negative 3x has to equal 3 raised to the 4th. Therefore, since the bases are the same, I can just drop them and say that the exponents have to also be the same. And when I divide by negative 3, I'm going to get x equals 4/3. How about another one? Solve 2 raised to the x plus 3 is equal to 8 raised to the 2x minus 1. Well, 8 can be written as a power of 2. So again, I've got 2 raised to some power over here. Well, this is equal to 2 cubed raised to the 2x minus 1 power. So 2 raised to the x plus 3 is going to equal, again, power to a power, multiply your exponents. So 3 times 2x minus 1 is going to be 6x minus 3. Since the bases are the same, I can drop them. So x plus 3 has to equal 6x minus 3. Solve for x, it's just a linear equation. So I can subtract the 6x from both sides. I can subtract the 3 from both the sides. This is going to give me minus 5x equals negative 6. When I divide by a negative 5, I'm going to get x equals 6 over 5. Let's try one more. Now here, the variable is actually the base itself. There's a couple of different approaches I could take to this. Actually, this is the same thing, recall, as the cube root of x to the 4th. So I could start solving for x by cubing both sides and doing the 4th root. Maybe it'd be better to do the 4th root first. In other words, I could do the 4th root of this is equal to the 4th root of this. So the 4th root of x to the 4th cancels. I've got the cube root of x equals 81 is 3 to the 4th. This is the 4th root of 3 to the 4th. So that's just 3. So if the cube root of x is equal to 3, I could get rid of that cube root by cubing both sides. Again, the power and the index, when they're the same, they cancel. They're inverse operations. So that's going to give me x equals 27. So these take a little practice, but they're not that bad once you get started on them.